Okay, let's look at example 17D. We are given sine of 28 degrees. Okay, so let's see. We have sine, which is what we want to keep. Can we get that 28 to be a relationship of 14? Okay, so we can say 28 minus 14 gives me 14. Okay, great. I could also say 28 divided by 2 gives me 14. Beautiful. So I know 28 is 14 and 14. So this is actually sine of 2 times 14 degrees. Now, what's your temptation at this point? What is wrong? What you should not do right now is to write that this is equal to sine of 2k. That is incorrect because the degree is 28. This is not equal to sine of k plus sine of k, or sine of 14 plus sine of 14. So let's have a look here. Let's see what we can come up with. What do I mean by that? Let's have a look. If I said sine of 14 plus sine of 14, let's put our bracket in there. We get that answer. Versus sine of 28. Not the same thing. Can you see that? 0,483 versus 0,469. Not the same thing. Okay. So instead, what I want you to recognize is this is 2 times an angle. What do we call 2 times an angle? We have a double angle, right? So let's use the double angle rule. According to the double angle rule, if you have sine 2 times an angle, you have 2 times sine 14, cosine of 14. So far, so good? I sincerely hope so. Okay, so now that we've got that, we want to see, this is what we want to keep. That 2 is okay, it doesn't bother us. But that cosine of 14, what are we going to do with it? Oh, can I go to my previous answer? I realize I should have taken that square off of that one. It's not square, it's actually degrees. 14 degrees. Okay. And the reason why I checked back there is because we're going to use this line. We've already proven. Remember, sine of 13, for this whole question, sine of 14 equals k. So everything is the same. Cos of 14 stays the same. So we're going to use that for cos of 14. And we're going to input that. We're going to say, okay, 2k, because we're substituting sine of 14 with that, multiplied by the square root of 1 squared minus k squared. Are you happy with that? So that's our final answer. 2k times the square root of 1 squared minus k squared. The end. That's D.